Alright, Dream Team, here we are for the second and final video of Skill 2. Hopefully by now you are comfortable with solving by factoring. When you see something like this, without even finding the axis of symmetry in the vertex, you can look at this guy and be like, hey, you know what? I think I have a 0 at 4. If I plug in 4, that will make this whole thing 0. And I got a 0 at -3. If I plug in a -3, it'll make this whole thing 0. Either way, it makes my equation 0. So on my graph, I have a 0 at 4 and a 0 at -3. My graph's going to look something like that. Cool? Hopefully you're good with that. That was the first part of this lesson. Alright? It's really nice when they give you an equation that looks like that and you can just fly. Now, check it out. Sometimes your equations will not have a real nice parentheses like that. So as I look at this equation, there's no parentheses. However, as I look at everything that's on the left-hand side here, I say to myself, is there anything I can factor out? If you remember, this is from a long time ago. Is there anything I could take out? A GCF I could take out of both of those? Well, I can see that the number in front is technically just a 1, so there's nothing I can take out of 1 and 4. However, I could take an n out of both of these because they each have an n, so I'm going to do that. I'm going to factor out an n. Alright? Which means what's left over in parentheses in this first term will just be a single n minus what's left over in this term is just the 4. Alright, hopefully this is all coming back. You're seeing where we're starting to tie all this stuff together. Alright? And now, as we look at this thing, we say, hey, what are the things I could plug in either here or here to get this thing to equal 0? Alright? And in this thing here, what could I plug in for n to get this to equal 0? Well, 0. Easy enough. That's one of our answers. And what could I plug in here to get this thing to equal 0? Think back to what we just did here. Positive 4 minus 4 equals 0. So our second 0 is 4. These are our answers. 0 and 4. Cool? So, if it doesn't look like this, the first thing you check for, number 1, is can I get a GCF? Okay, can I get a factor that I can pull out of both? Alright, so let's do that. Let's look at this here. Here's our next one. Alright, I forgot to write that it equals 0. Alright, so there's no nice parentheses. Can we get a GCF? Is there anything we can pull out of each of these? Well, the number in front here is a 1, right? So 1, 4, 5, I don't think so. This has 2 x's, this has 1 x, this doesn't have any. There's nothing we can pull out. Okay, so step 2. First, can I get a GCF? If you can't get a GCF, you're going to factor this. Alright, now, this is a blast from the past for you guys. Here we go. Remember what goes on top? A times C, right? A is 1, C is -5. I think that's just a -5. On bottom goes what? Hopefully you're thinking B, which is -4. So we need two numbers that multiply to -5, add up to -4. Here we go. The only two numbers in the whole wide world that multiply to 5 are 5 and 1. Alright? Since one of them's got to be negative, and they add up to a negative number, the bigger one's going to be negative. So -5 and 1 are my solutions. And then as you remember from the previous chapters, we now divide these guys both by A, which is 1. Alright? And then, we've said it a million times, we go from bottom to top. Bottom to top. Here we go. This solution here looks like this. 1x minus 5, right? And this solution over here is just 1x plus 1, which we don't even really need to put the 1's in front, correct? Guess what, you guys? Take a look. Look really closely at this thing. Really close right here. Doesn't that look exactly like that really easy stuff we did earlier this skill? Exactly the same. So here we go. Our 0 here, what will we plug in to get this to equal 0? That's right, positive 5. And what will we plug in here to get this parentheses to equal 0? That's right, -1. Our solutions are 5 and -1. So we are bringing back For some problems, we're bringing back the GCF method, and for some problems, we're bringing back the X method of factoring. Let's look at this one right here. This is going to be a combo of both. So, step 1, do we have a GCF? So I look at the numbers 3, 12, and 12. Alright, I forgot to write equals 0 here. 3, 12, and 12. Can we pull out a number out of 3, 12, and 12? I think we can. I think we can take a 3 out of each term. So I'm going to write that down and write 3. And then we're going to write the leftovers in parentheses. Alright? So, we're going to look at that first term. Here we go. When I take a 3 out of here, all that's left is x squared. When I take a 3 out of here, we're technically dividing, so we get negative 4x. And when I take a 3 out of here, we're technically dividing that 3, so we get positive 4. Alright, boom, here we are so far. This problem right here still is not super nice, so we have to now combine it with step 2, and we have to do our factoring. Alright, so we're going to take just the stuff in green, and we're going to do our X method of factoring. So I got my A times C, I got my B. A times C is just going to be 4, and B is going to be negative 4. So we need two numbers that multiply to equal positive 4 and add up to equal negative 4. Well, if they multiply to be positive and add up to be negative, I know they're both going to be negative. And it's looking to me like our numbers are 2 and 2. Double check. Negative 2 times negative 2 is 4. Negative 2 plus negative 2 is negative 4. Perfect. And now we just have to divide them both by A, which in this case is 1. And so our solutions here are going to be bottom to top, 1 minus 2. 1x minus 2. And over here, in the second one, also 1x minus 2 equals 0. And don't forget, you guys, we pulled out a 3, so that 3 is still sitting in front. And this is our final extended equation. I'm going to get rid of the 1's. But once again, we have to just look at the parentheses. What would make that equal to 0? 2. If we plug in a 2, that would make that equal to 0. What would make this parentheses equal to 0? Also a 2. So this problem right here has only one solution, and that is 2. If we were to draw that on a graph, at the point 2 here would be the only spot where it hits 0. Alright, so quick recap. And if you need to go back and watch the video slower, go for it. If they give you parentheses already, if they break it down already, it's easy. Just find the zeros. Alright? If they don't, step 1, can I get a GCF? Step 2, the X method of factoring. Alright, those 1, 2 steps are going to